Hi, Mr. Hanna here. In this video we're going to be solving trigonometric equations. And we're just going to be doing this using examples. So here's the first one. It's saying solve sine of 2 theta equals negative root 3 on 2. And there's a domain restriction that theta has to be between negative pi and pi. Okay, first before we actually solve it, I just want to think about what we're actually trying to do here. So what I want to do is I want to graph this. I want to graph y equals sine of 2 times theta. Okay, so let me just do that quick graph, and I'm going to do it within the right domain here. So between negative pi and pi, this is our theta, and here's our y coordinate. Now 2 theta, that means it's been sort of squashed to 2. So here our period is 2. Our amplitude is 1. Amplitude equals 1, and our mean, there's nothing shifting it up, so our mean is 0 here. So it goes along here. So that means it will have a maximum of 1, minimum of -1, and I'll split it into quarters now. So sine graph hasn't been reflected, so it goes through these points. And then down. Okay, so it will look like this. Okay, now what we're trying to do is find when this graph equals negative root 3 on 2. Now, negative root 3 on 2 is less than negative 1. So let me draw it in with I'll use a dashed line. So here, this dashed line here, that is roughly, this dashed line is y equals negative root 3 on 2. So from our quick sketch, you can see that we might expect 3 solutions. This point here, and this point here. So that's what we're actually trying to do, and it's important that you have an understanding of what we're actually trying to achieve when we solve a question like that, even though it didn't ask us to graph it, so we didn't need to graph it, and there's a better way to solve this than using a graph, in fact. So, and that is thinking about our unit circle. So let's find our first sort of solution, if you like. So let's find what 2 theta could be. So 2 theta could be, so first what I'm going to do is I'm going to do inverse sine of both sides. So I'm going to do the inverse sine of negative root 3 on 2. Now I do know from my perfect triangle, of course, so well, first off, I could use a calculator to do that. Okay, so you could use a calculator to do that, but I know from my perfect triangle I've got a 1, 2, root 3 triangle. And it's got, this angle is pi on 3, this one is pi on 6, that's right angle there. So inverse sine of negative root 3 on 2, to get sine of that, it's this angle it's talking about, this one here, because root 3 is the opposite side and 2 is a hypotenuse. So our base sort of angle we're working off is pi on 3. But if we look at our unit circle, here all of them are positive, here sine's positive, quadrant 3 tan's positive, and quadrant 4 cosine is positive. Now here it's giving us a negative root 3 on 2. So we must be either in quadrant 3 or quadrant 4, because that's where sine is negative. So we must either have this case here, or this case here, where this angle and that little angle there are pi on 3. So that means this first one over here, the quadrant 3 one, to go all the way around, is pi plus pi on 3. In other words, that's 4 pi on 3. So one of our solutions here, 4 pi on 3. And this one over here, that's 2 pi. So that's a whole revolution, 2 pi, take away pi on 3. So that one's, we can think of as 2 pi take away pi on 3. In other words, that is 5 pi on 3. So that one is 5 pi on 3. Now we can do our next lot, go the whole way around if we like. The whole way around gives us 4 pi on 3 plus another 2 pi, 10 pi on 3, because 2 pi is of course 6 pi on 3. And then this one, that will be 11 pi on 3, and there are more of them as well. Now going in the negatives, to get this angle here, that's like going here to negative pi on 3. So this one's negative pi on 3. And we've got another negative one if we do from here there. That is negative 2 pi on 3. Because it's not quite negative pi. And then we've got some other ones as well, like if we take away 2 pi, so if we go start here, go all the way around, that's negative 2 pi plus a little bit more. So that's negative 7 pi on 3. And if we go from minus 4 pi on 3 and another whole lap backwards, that is, oh sorry, that's a 2 pi on 3. That would be negative 8 pi on 3. So here's a whole bunch of solutions. Some of them we won't need. Now remember, these values are 2 theta. 2 theta equals those values. So now, to get just theta, we have to halve them all. We have to halve them all. So this one, to halve 8 pi on 3, it's 8 pi on 6. Basically, to halve them all, we just make the denominators all 6. So we get minus 7 pi on 6, minus 2 pi on 6, minus pi on 6, 4 pi on 6, 5 pi on 6, 10 pi on 6, 11 pi on 6, and so on. Okay, so there's more, and they just keep going infinitely. Now we look at our domain. We know that we're only interested in ones that are larger or equal to negative pi, or smaller than or equal to pi. So, first off, this one, negative 8 pi on 6, that is smaller than pi on 6, so not that one. Similar with negative 7 pi on 6, so we're not going to use that one. But negative 2 pi on 6, which of course is the same as negative pi on 3, that is within our domain. Negative pi on 6, so negative pi on 6 is also in our domain. 4 pi on 6 is the same thing as 2 pi on 3, which is less than pi, so that one's in. 5 pi on 6 is also in. 5 pi on 6 because it is less than pi. 10 pi on 6, which is the same as 5 pi on 3, that's bigger than pi, so that one doesn't count, and that one's bigger than pi as well. So here we have 4 solutions for theta. Now here when I said we only have 3, that's because I must have forgotten this last point to pi, where this graph comes and does that. So there are actually 4. Sorry, I misled you a little bit there. So there are 4. And here are those 4 solutions for you. So there we go, that is our first example. Now you can see that I did a little bit of extra work here by putting 2 on the extra sides. Now it's important that you have, I maybe didn't need to do 2, but it's important to always have 1, just so you're confident you've got all of the possible solutions. So I just wanted to note that. So there we go. Now let's do our second example. Okay, so this example we've got sketch y equals minus 2 cos x plus 1. So here we've got a reflection, we've got a dilation of 2, so the amplitude is 2, and we've got a translation of 1. So let's quickly write some of those things down. So the translation of 1 means that our mean is at 1. The 2 here means that our amplitude is at 2. It has been reflected, so we're just going to write that down. Reflected, and our period hasn't been dilated, so our period is just the normal old 2 pi period. Okay, so let's start sketching this up. Oh, we should also be putting on a domain restriction. So let me add a domain restriction. Well, let's make the domain restriction x being, I'll make the square brackets, between negative pi and 2 pi. There we go. Okay, so now we're ready to sketch this up. Oops, that needs to go a bit higher. Okay. So this is our y-axis here. Alright, so we've got a mean of 1 and amplitude of 2, so it's going to go as high as 3 at a maximum and as low as -1. So let me put in a dotted line to make this a bit more clear for everyone. Period of 2 pi, so that means, and we're going up to 2 pi, so let's make that 2, oops. Make that 2 pi there. And negative pi in this direction. Oops, that's probably a bit too far away. Negative pi. Okay, so here we'll have pi on 2. Just breaking this into quarters. 3 pi on 2. And here negative pi on 2. Okay, there we go. So now we're ready to sketch it. So it's a cosine graph, but it's been reflected. So we start at the minimum and go down. So it's there, then we're going to have one here, 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 and here. Okay, I'm ready to sketch this. Okay, so there we go. So our basic sketch is done. Our basic sketch is done. But one thing we haven't done is found these two x-intercepts. So we need to find the x-intercepts. Because we've got the y-intercept as well. Find the x-intercepts. Now to find the x-intercepts, we have to set y to be 0. So y is 0 for the x-intercepts. In other words, to find the x-intercepts, we need to solve for -2 cosine x plus 1 equals 0, because y is 0. So let's rearrange this. We get cosine of x. So first we're taking away 1 and then dividing by -2. So if we take away, so let's do this in steps. -2, -1. Now I'll divide by -2. There we go. So we have cosine of x equals 1/2. So I've divided by -1 by -2. Okay, so now what I'm going to do is find all the different points for which this is true. So first I can find my first one by doing the inverse of cos. So here at this point, just make a note that I could do to find the first one, x equals the inverse of, 1/2. To find that, and I do that on the calculator. Or I can use my perfect triangle, which I'm going to do. Because I know that I have this triangle at my disposal, 1, 2, √3. And this is pi on 3, this is pi on 6. So here, cosine of 1/2, so this 1 must be the adjacent side, and the 2 must be the opposite side, so that's pi on 3. So our base angle is pi on 3 in this case. Now I'm going to get out my unit circle. Because I'm looking for positive, so a positive half. So the regions in which cosine are positive are this one, first quadrant, and this one. So all are positive here, cosine is positive here. So these are the two quadrants. So I'm going to have these two bits where either this bit here is pi on 3, or this bit here is pi on 3. So if this bit's pi on 3, then our angle is pi on 3. So the first one, x, is equal to pi on 3. Now this one here is a full lap around to here. So that's, in other words, that's 2 pi minus pi on 3, which of course is 5 pi on 3. Now if I was going to go another one around, it'd be 2 pi, it'd be all the way around 2 pi plus another pi on 3. So that is 7 pi on 3, and there are more as well if I want to. I can also go backwards, so this first one going backwards is negative pi on 3. And this other one, if I go all the way to here, that is negative 5 pi on 3. And I can do more, keep going backwards if I need them. Because my job now is to find which ones of these fit into our domain at the top here. So, first off, it can't be smaller than negative pi. Well, negative 5 pi on 3 is smaller than negative pi, so that one doesn't count. And they can't be bigger than 2 pi. Well, 7 pi on 3 is too big, so that one doesn't count. Because we've got one on both sides that aren't included, that means we have definitely found all of the ones that we need. So there are 3 solutions here. So x is equal to minus pi on 3, and 5 pi on 3. And you can see those 3 points on our graph, and so we can now mark them in. So this one here must be minus pi on 3. So that one is minus pi on 3. This one here must be pi on 3. Pi on 3 for this point. And this point here must be our 5 pi on 3. 5 pi on 3 for that bit there. So there we go, we have sketched we've finished the question as we have sketched our original equation, showing all the axis-intercepts, the mean value, the amplitude, and the period. So that's very good, and we've made sure it's in our domain. So there we go. Hopefully those are enough examples to set you up. So all the best. See you in class.